Coming up on this episode of DevelopSec, we discuss code review versus static analysis and how to use them both. Tackling the challenge to integrate security into the development process? Looking for insights, answers, and practical solutions to avoid getting overwhelmed? Welcome to DevelopSec Live, where our focus is your success in securing and improving development processes. And here is your host, James Jardine.
Hey everyone, today I want to talk about code review and maybe compare that a little bit to static analysis. And I see a lot of places these days, they use static analysis as their version of code review, and that may not be the best full solution that we're looking for. So notice I talk about code review, and I'm not saying secure code review. Now, in reality, I'm really talking about secure code review, but if you listen to anything that I talk about, I have a long-going theme here that basically I'm trying to embed security into what we currently do. And my hope is that you currently have code review actually going on within your organization. So by me just saying code review, we're going to embed security into that process. And that's what we're hoping for. So if you don't have code review already going on, it's going to be difficult to start implementing secure code review, at least from a peer code review side, if we don't already have something happening internally. So we want to push for that idea that our SDLC or secure SDLC should already have something designed in there that says we do code review of some sort. And then we got to start asking the questions of what do we do with that code review so we can start understanding that. Now, I mentioned code review versus static analysis. We see a lot of places now that consider basically static analysis as our code review, and we replace it as our code review. So instead of saying, hey, we need to actually have somebody manually review this code base, we run it through a static analysis tool, and then we say, okay, we've done code review, and we're done. And like I said, I've seen major places that are starting to push where they're willing to replace or forego their typical code review and instead use static analysis and the results from that and qualify that and quantify that as the code review for their system. And you know, there's a big difference between these two things. So if we talk about static analysis for a second, static analysis is the automation, and it's an automated tool of scanning your code base, whether it's the actual code or whether it's a binary, right, the compiled version of your code, to look for potential security weaknesses. And it does this in a few different ways. We've talked about static analysis in the past. And a few ways that it does, right? I can look for keyword type things. That's how I was finding password issues, hard-coded passwords, hard-coded keys, that type of stuff. But it also will do data flow, and it'll look to see how data enters the application, how it flows through the application, and then how it comes back out of the application. And this is good for things like SQL injection, cross-site scripting, all these injection attack type flaws, information leakage type flaws. They can be identified through static analysis. There are good things that it can find, and it can find them quickly. The other nice thing about static analysis is that it automatically works the same way every time. So if I run that same tool against the same code base, I should expect to get the same results every time I run that. Compare that now to a code review, which is a manual code review. This is me going through the application, inspecting the code to determine what it's doing and what potential risks may be there. Depending on the person doing it, and even taking the same person and giving them some time in between reviews, the same code base, they may come up with different results. They may find one thing this time and not find it the next. They may miss something the first time and then find it the next time, right? So compared to automated scans, which run the same exact process every time and find the same things until we update the scanners, the manual side is heavily dependent on the person you have doing the actual scan. So they are not the same. Neither one is going to be 100% reliable by itself, as we know this from security, that we need to have multiple layers in place here. A lot of times, though, what I see is we use static analysis as part of our code review to help speed things up. Because as I mentioned, static analysis is actually really good at finding things like cross-site scripting, SQL injection, the injection family of flaws. It's quick at finding it. So if I can use that to help build that up and help me out when I do the manual process, then I can change what it is I'm doing from a manual process and allow the automated process to do its thing. But I can't sit there and say, hey, I did a static analysis scan, so I've done code review. That doesn't really line up. In a lot of places, I think we overabuse the term code review to where I've seen so many places call up and are like, hey, can we do a code review? We've got 500,000 lines of code. We need it next week. And I'm like, no, you can't do a code review in that amount of time. Nobody can do a code review in that amount of time. Not a real code review. You can run a static analysis tool and take the results from that tool, maybe analyze some of the false positives or false negatives, weed them out, put them in a custom report and send it over in a week. But you're not doing a full code review on 500,000 lines of code unless you have a ton of people dumping on top of this thing in that short amount of time, because there's a lot that goes into it. There's a lot of expertise that you have to have. And so code review is interesting to me because we're going to talk about hiring in another episode, but I look all the time at all these job requirements that we see for application security engineers. And, they want pen testers, they want code reviewers, they want policy writers, they want all these different things. And they're really different skill sets. To be able to go through and test an application for cross-site scripting dynamically by using the application is very different than being able to look at the source code and be able to identify where cross-site scripting is, or look at the source code and be able to identify where there's a weakness in that code base. Just because you know how to use the app does not mean you know how the code behind the app actually works, and that makes it very difficult. And then you set up in your organization, say, all right, this guy's doing code reviews for you now, but they don't know the language. They don't know what they're covering. They're going off of, tool results, and that's about it. And then we classify that as a code review. And that's kind of a false sense of security in that sense, because we're taking something that's not meant to be a code review and we're using it as that code review. So we got to be conscious of that as you're going through doing this within your organization to make sure that what you're doing actually lines up with what you're expecting to see. Now, there's two types of code review that we really see out there. We have peer reviews, and this, of course, is done by other developers looking at smaller bits of code. And then we have the full review. Now, the full review is, hey, I'm going to take my entire code base and I'm going to ship it to somebody so they can do a review on this code base for us. Now, there's kind of some neat things about how these two run differently. So let's take a look at a few of these. So peer review, mostly done internal because it's on a smaller code base, right? I've done a few modifications. I've wrote a new function. Now I want somebody to review that code for me and validate that I've followed the rules that we expect, that nothing is popping out. Now, oftentimes, a lot of organizations already have peer code review going on. It's part of their SDLC, that when you write code, somebody else has to review it. The problem is a lot of times we're not taking in security as a consideration to that review. And so we need to start embedding that as part of that. Now, I talked last episode, or maybe the episode before that, I apologize. I talked in one of my previous episodes about coding standards and embedding secure coding standards within our current coding standards. Because when we say, hey, I want you to go review James' code, what are you looking for? Are you just looking to make sure it looks pretty? Or do you have certain things that you're looking for? Do you have guidelines that say this is how the structure of the code should be, that you shouldn't have more than X number of lines in any given method? Whatever that may be, what are you looking for? You have to have some baseline to know that. Well, then we tack on security standards on top of that, but that should exist within your coding standards. So you can say, oh, I see we're doing a database connection here, and our standards say this is how a connection should be done. If it's done any other way, we need an exception for it, and hopefully a good reason for why we're doing it this way and we can't do it the way that's in our guidelines. So again, now we're saying, hey, we want to do a review. We have guidelines. This is what we're reviewing for, and we're going to do it consistently. Now go forth and verify those. And when you come back and say, hey, it's not necessarily I'm saying you have SQL injection here. What I'm telling you is you're accessing SQL in a way that's outside of our guidelines for how we should be connecting to our database. We should be using parameterized queries. We should be doing this. We should be doing that. Your code is doing this. We need to fix this before we move forward. That's what we're going to see in that peer review. So again, it's internal. It's people that know the apps. It's much quicker than what we're going to see. When we see that full review, now remember, we're talking about the whole code base. So now we're going to send that either to an internal group that's external of our development team, or we're going to send it externally to a third party. Now, of course, when we do that, this raises up the cost. Okay, so a peer review is pretty cheap internally because it's our own resources. It's on smaller code bases, so it's a lot cheaper. When you look at a full review, now we start getting into much more expensive because we're sending that out to another organization most likely, or we've got internal resources that we're paying an absorbent amount to be able to go through and have the specialty to be able to perform these reviews. And then add on the amount of time, which of course is directly related to the cost that it takes to perform these reviews. Peer reviews are usually pretty quick because it's on smaller code bases. It's the small change you just did. We're going to just look at that. So maybe I'm looking at, 100, 200, 1,000 lines of code versus 500,000, 1 million lines of code that I'm trying to go in and review. So obviously the time difference is huge there. And so that makes a big difference. And of course, the shorter the time difference, the easier things go if it's embedded in. Imagine if we were doing peer reviews, they don't take very long. We check in new code, somebody reviews it, we validate it's good. If there's an issue, we turn it around, we get it resolved, and back through the process. We're ready to hit our normal deadlines. If I'm going to do a full review, now I got to ship that code base off. I got to hope nothing changes in that code base, because as soon as you ship it and start changing, the code base is stale. So I'm reviewing code that could have already changed. It's going to take me a while to do it, so this could slow down release, especially if I find issues that need to be resolved. But it takes me a month to review the code. This is much more difficult, much more time-consuming, and a consideration that we have to really take in when we're talking about what we're doing for reviews. Now, oftentimes we only see full reviews maybe once a year, maybe on huge major rewrites, big releases. Then we see those full reviews. Otherwise, we typically see the peer review as the way to go to bring that in there. Now, the other thing I want to talk about, and this relates to the cost and it relates to the time. When we talk about code review, OWASP has a pretty cool document out there describing how to do code review. It's a great resource. Go check it out on owasp.org. But one of the things they point out is that the average rate for doing code review is 200 lines per hour. So 200 lines of code per hour. So I broke down here, if I have 500,000 lines of code and I'm only doing 200 lines per hour, that's 2,500 hours that I've actually got that I have to do code review on. So if I go out and do it at 200 lines per hour, that's almost a year at 8-hour days that it's going to take for one person to go through and do that code review. Now, of course, you can throw multiple people at this and try to break it down and beat it up and get it done a little bit quicker. But still, at 200 lines per hour, that's pretty slow. I find more realistically, you're looking at something like 2,000 lines per hour. And I know that sounds like a lot, but if you break that down, now you're looking at 250 hours or 31 days of one person. So you're looking at a month to be able to get this turnaround. Now, how do we get 2,000 lines per hour, though? Because if you imagine sitting down trying to look through the code base, there could be a lot of code. It could take a while to go through, 2,000 lines. What's in there? What counts as a line? That's a good question. Does a line with a curly brace count as a line? How do we count those lines? But also, when we talk about 2,000 lines per hour, we're also talking about using static analysis in conjunction with what we're doing. So it's not just a full 100% manual review of the application. It's, hey, I'm going to run a static analysis tool. It's going to go through and it's going to find a wide swath of vulnerabilities for me. It's going to look for these things. And then manually, I'm going to go through using a checklist, and I'm going to figure out how to best review and spend my time reviewing this code for security issues. So maybe I'm going to spend my time looking for things like authentication issues. When we're looking about the login screen and all the login functionality, I'm looking at the log out functionality and how that works. I'm looking at session management and how we're doing session management, right? I'm not starting at the top of every file and just going down one line by one line doing a code review of my application. That's a poor way to do a code review. You want to have a purpose, right? There's a reason why you're going into certain things. Oftentimes, before we do that code review, we kind of do these questionnaires and we want to find out, hey, tell me about the application. What features do you have? Do you have authentication? Do you have login screens? Do you have logout? Do you have CSRF protections in place? Because I want to know where to go look for where that may be implemented. Anything else you have? Do you have file upload capabilities? Yes? All right, good, because I want to go target that. But if you just give me the source code for 500,000 lines of code, and then I'm trying to find where these certain things are, like, I don't know if there's file upload. Sure, I can write little tools that'll help me enumerate the code and identify file upload controls or objects that are used for file upload, but that's not a good efficient use of the time. If I do the survey beforehand and I say, hey, tell me about your app, what do you have for components out here? Then we can quickly come in, we can hit those spots. Now remember, when we're doing this code review, again, we're not just going through line by line. What I'm doing is I'm going to pick a spot. I'm going to do authentication. I want to look at your login functionality. And when I'm looking at the login functionality, I'm looking around the login functionality. So I'm checking it, I'm tracing it, I'm seeing how it works, and then I'm looking around it. So everything I'm looking at, I use my peripheral vision, and I'm looking up a little bit. I'm looking down a little bit. What's around this code? And does anything stand out as a potential issue? So I start kind of chaining out a little bit to see what else I can identify as I'm doing this. But I've got key elements that I want to inspect from a code review standpoint. And there's also other automated tools you can write. I know a lot of people write their own scripts to be able to help go through and perform these code reviews so that way they can pick out certain things really quickly. Maybe I want to see, hey, do you use certain objects? Let me have a script that runs through all the files and sees if that object exists. And I can go hit that object real quick and see, hey, how are they doing this? But we also have to remember, we have to understand configuration of the application. You think, use .NET as an example, there's a lot of things I can configure within .NET, within the web config files, that it changes how my application works very much so. So if I turn off certain controls that already exist, then when I'm reviewing the code, if I don't know that's on or off, that may change how I view some of that code. There are certain things by default in .NET that are protected against. Example, enable header checking is on by default. So it's pretty difficult to actually do response splitting or being able to get carriage return line feeds within header output within .NET unless you're using some random one-off way like response.writing it. But if most of the controls or objects that you use to add cookies, different things like that, adding headers, it automatically will block out and encode any type of carriage return line feed to protect against some of these issues. So by default, I'm looking and saying, okay, we're good here. We're using these objects. It's fine. We're protected. But what if I go look in the config and find out that we're not protected? Or what if I decide that, look, I'm going to still write this up and say, hey, we've got this issue. You've technically got insecure code in the fact that you're taking untrusted input and you're sending it out as a response header, but you have a protection in place that is protecting against this because by default, this value is on. But if you change this value, it could change. So does that change the priority level of the issue that we have within our code? Maybe it does. Maybe all of a sudden what may have from a tool been considered a high vulnerability really is a low risk because we verify our configs. Here's our process for verifying our configs. And we have a backup system that IIS is also going to block out and reject carriage return line feeds within our header objects. So we're pretty comfortable here that, yeah, there's an issue. Let's go back and look at our coding standards and see, do we want to update this? But am I going to stop everything I'm doing to try to resolve that flaw? Probably not, because the risk level of exploitation is so low that it requires that human error to update our config file, to remove that, to downgrade our IIS to be before IIS 7, which probably is not going to happen. There's lots of things that go into that. So that brings me to understanding the context of our applications. Static analysis doesn't know what systems our code is running on, doesn't know whether we're in IIS 7, doesn't know if we're in Apache, doesn't know this stuff. All right, but manual review, we know this stuff, and we can take that context and put it into what we're doing in our applications in that review, so that way when we get these results and we get ready to pass them back over, we know how serious they are. We know what they may affect, what they may not affect. And we're removing a lot of that burden off the development side to have to try to figure that out and see how that's going to work to protect us. So code reviews, it's important. And remember, it relies heavily on the person doing the code review. There are a lot of people that'll say, yeah, I can do code review. Just because you can test applications doesn't mean you can do code review. So if you're a customer looking for somebody to do code review, I encourage you to make sure that you understand what it is that's actually being done when you're outsourcing the code review. So if you're saying, hey, I want a code review, and you're paying lots of money for a code review, make sure you're not just paying lots of money for a static analysis tool and then somebody just to convert those items over to a independent report that doesn't look like a static analysis tool, and then giving you that and feeling as though you've gotten a full code review. If what you're looking for is somebody to run static analysis and do that, false positive, false negative legwork for you, that's great, as long as you're aware that that's what you're looking for and that's what you're getting. But if you're actually looking for a code review, a real code review, make sure that that's what you're getting is a real code review. Understand the processes that people are going through. What's their technique for going through an application and identifying vulnerabilities? What's their experience with that language? Because going in and doing a code review is very language specific. If you're an expert in Java and then you go try to do a code review of C, that's not going to turn out very well. You're going to do a lot of Googling. You're going to hope you find some of the key things. But if you're not experienced in that language, you're not going to pick up on those small little items that may make a big difference security-wise, but don't look like that big of a deal within the application. So things to consider when you're considering going out and doing code reviews: make sure you start with understanding what it is you're trying to do. What's your end goal for your code review? Make sure you have coding guidelines in place. Otherwise, what are you code reviewing against? Make sure you have these guidelines in place. And if you've done the code review, take those results and go compare those to the guidelines. See if you're missing stuff in those guidelines. And if you are, take those results, determine how you could work those into the guidelines, and then move them into the guidelines. So that way it just becomes the way you're doing things. You'll start protecting against this. So often we take the results, we send it to a developer, they fix those results, and we continue doing the same cycle over and over again. We don't update our guidelines. We don't update the way we're doing things. Our way of doing things is reactive. It's you found something, I fixed something. Instead of you found something, I figured out why we had that. Now, how can we not do that going forward? Let's update that process and move it in. Same thing we do with everything else. And that's going to be another topic that we'll discuss on another episode, as far as getting those processes in place and how do we handle and how do we analyze the results of code reviews, of pen tests, of all these different things that we want to handle. How do we go about doing that to make sure that we're not doing the same process over and over again, but instead actually sitting there and making sure that what we're doing is making a difference in the future of what we're doing. We can pass this back around and make everything work to our advantage. So I appreciate everybody tuning in, listening to this. If you've got thoughts about code review, questions about code review, feel free to send them my way, james@developsec.com, or you can reach me at DevelopSec on Twitter. Happy to have any conversations about that, share any knowledge or experience that I have with it. because I think it's important. So I want everybody to get the information that they need to make the decisions that they feel confident about in helping protect their applications and help building up their mature application security program within your organization. So thanks again for tuning in, and we'll catch you on the next episode.